status explains how multiple genotypes can present the same phenotype. One gene is affected by the expression of one or more independently inherited genes. This is different from the simple Mendelian genetics that we have learned thus far. In epistasis, the gene that does the masking is called an epistatic gene, and the gene whose effect is masked is a hypostatic gene. Epistatic genes may be recessive or dominant in their effects. You guys seem to be affected by single recessive epistasis, which will explain how you are both yellow Labradors but do not have the same genotype, as seen below. Now let's look at a biochemical genetic pathway. As seen in the biochemical genetic pathway, the presence of the genotype a at the second locus masks the expression of the black and brown alleles at the first locus. In this example of gene interaction, allele a is epistatic to big B and little b because little a masks the expression of alleles for black and brown pigments for Labrador coat color, and alleles big B and little b are hypostatic to little a. Little a is recessive epistatic allele because two copies of little a must be present to mask the expression of the black and brown pigments as seen in the diagram. Let's first begin by looking at a dihybrid cross example. 9 black Labradors are produced, 3 brown Labradors, and 4 yellow. But let's take note that the yellow Labradors produced are combined for 3 different genotypes. Little a, big B, little a, big B, and little a, little b. Let's look at Scout and Bear specific parental genotypes. They are big A, little b, and little a, big B, little b. From this cross, 8 yellow Labradors are produced, 4 black Labradors, and 4 brown Labradors. Let's take note, though, that out of the 8 yellow squares shaded in, 3 different genotypes are presented. This is how single recessive epistasis affects the presentation of the big B and little b allele. The little a masks the presence of those 2 alleles, making a yellow Labrador.